Good day, students. Welcome to part two of the review series. We're going to be focusing on right triangle trig and the Pythagorean theorem in this set of problems. Okay. All right. Let's go ahead and take a look at question number 4. It says a new pipeline is being constructed uh, to route oil flow around the exterior of a national wildlife preserve. The plan showing the old pipeline and the new route is shown below. About how many extra miles will the oil flow once the new route is established? So um, this is the reserve right here, the preserve, sorry. This is the preserve right here. We have a rerouting taking place. So this is a new route, and this is the old route. The new route is a little bit longer. So the question is, after this new route is completed, how many extra miles uh, will the oil flow? Okay. So in order to determine what how much longer the new pipeline is, we need to figure out the length of the old pipeline. Okay, so we know that the new pipeline is 28 plus 21 miles long. You go starting from here, 21 plus 28. So the oil is going to flow 49 miles. For the old pipeline, we don't know what it is, but since this is a right triangle, we can use Pythagorean theorem to simply figure out what the length of the old pipeline is, okay? So how about we just make a sketch of the triangle, and then we're going to put in the measures and figure out the length of the old pipeline, okay? So there goes a right triangle right there. This is a right triangle with a 90-degree angle. So opposite the 90-degree angle is the hypotenuse. I'm going to call this C, and then call this A, which is 28, and then let's call this B. Now, whenever you're using Pythagorean theorem, the legs do not matter how you label. It doesn't matter how you label the legs, um, but the hypotenuse is always C. So you gotta keep that in mind. All right. So C is actually the length of the whole pipeline. So to figure that out, let's write down the Pythagorean theorem. C squared equals A squared plus B squared. So we have C squared equals 28 squared plus 21 squared. So we have C squared equals, let's plug that into our calculators and see what we get. So C, 28 square plus 21 square is 1225. Okay, so C square is 1225. So to get C, all we'll just simply do is we're going to take the square root of both sides. So take the square root of that and the square root of that. And we have C equals, well, let's see, what is the square root of 1225? So square root, I'm going to insert the answer using the second function negative, 35. Okay, so C is 35. All right, so the old pipeline is 35 miles long. All right, so let's be careful with what the question asks us. It said, how many extra miles will the oil flow in the new one? So the extra miles is simply the difference. Okay, so extra mile traveled, extra miles traveled is basically the new minus the old, right? So the new is, what was the new again? 49. 49 minus the old, which is 35. So 49 minus 35 is 14 miles. So our correct answer is option A. Okay? All right, let's move on to the next question. Question 5, it says, what is the approximate height in feet of the tree in the figure below? So we have a right triangle situation here also. But we're given an angle, so let's complete the right triangle. We can use right triangle trigonometry. All right, so what am I talking about? I am talking about Sohcahtoa. Okay, that's right triangle trig. All right, so what do we have here? We're going to focus on what we need and what we know, and then that will help us determine the right ratio to use, if it's sine, cosine, or tangent. Okay, so let's see. We're looking for the height of the tree. Let's call that x, and then we know what this is. So the angle that we're given, this is the angle that we're given right here, 54 degrees. If this is a reference angle, that means the side opposite the angle is going to be called your opposite, okay, for O. And this side opposite the 90 degrees is your hypotenuse. Now this is the adjacent. In this problem, we don't know the adjacent, we don't need it, so we just scrap it. Plays no role here. So we just want to focus on opposite, what we need, and the hypotenuse, which we know. So what trig ratio has O and H in it? It's obviously sine, right? So sine is a trig ratio that we're going to use to solve this problem. All right, so sine 54 equals opposite over hypotenuse. All right, so to isolate x, we multiply both sides by 88. So the height of the tree x is going to be 88 sine 54. So let's plug that into our calculators and see what we get. 88 sine 54. And the answer is 71.2 to 2 decimal places. So it is approximately 71.2 feet. So the correct answer is option A. Okay? All right. Let's go ahead and move on to question number 6. It says the right triangle's hypotenuse has length 20. If one leg has length 10, what is the length of the other leg? Okay? So remember the legs are A and B, and the hypotenuse is always C. Okay, so we know that A, we can call A 10, and we can call B question mark as indicating that we do not know, and C equals 20. All right, we can use the Pythagorean theorem here because we deal with a right triangle. Okay, so the right triangle relationship between the lengths are the hypotenuse square equals the sum of the squares of the legs, A squared plus B squared. Okay, let's populate this equation with what we know and what we need. So we have 20 squared equals 10 squared plus B squared. 20 squared is 400, and 10 squared is 100 plus B squared. Okay, now we'll subtract 100 from both sides. Subtract 100, subtract 100. Using the reflexive property of equality, we can rewrite this as B squared equals 400 minus 100 is 300. Okay, now to get B by itself, you just simply take the square root of both sides, and then we'll have B equals the square root of 300. So the answer for number 6 is option A. All right, let's move on to the next question. Uh, question 7. It says to find out the height of a tower, a surveyor positions a small transit that is 2 meters tall at a spot 85 meters from the base of a tower. She measures the angle of elevation to the top of the tower to be 29 degrees. What is the height of the tower to the nearest meter? Okay, so let's go ahead and make a sketch of the situation. So we have a transit positioned 85 meters from the base of a tower. So let's say this is a tower right here. So we have the transit is 85 meters away from the base of the tower. 85. The transit is not on the ground. The transit has a height of 2 meters. Okay? So the height of the transit from the ground is 2 meters. All right, so this is the ground right here. All right, so we can even put the legs of the transit. Well, let me not get you confused. So let's just do it like this. So there goes the transit right there. And then we have the lady standing right here, and she's looking into the transit. Obviously, she wants to have it at eyesight, so that's why it has a 2 meters off the ground. Okay, so the height of the transit is 2 meters. This is 2, so that means this is 2 also. And the angle of elevation to the top of the tower of the transit is 29 degrees. So this is 29 degrees elevation from the line of sight or the horizontal. So let's label that. This is 29 degrees. So the question said, what is the height of the tower? So the height of the tower, we're going to find this length right here, and then we're going to add it to the height of the transit, and that will give us the height of the tower. Okay, so we want to find that length, whatever that is, plus the height of the transit, that will give us the height of the tower. Okay, so let's call this x. All right, so we have a right triangle trig scenario here because we have two sides and an angle being involved. So what trig ratio are we going to use in Sohcahtoa? Is it sine, cosine, or tangent? All right, let's look at what we need and what we... All right, so This is the reference angle, so that means the side opposite it, this side right here, is going to be the opposite, which is the side we need. And this side right here is the adjacent, which is the side we know. The hypotenuse opposite the 90 degrees, we don't need it, we don't know it, so forget about it, all right? So which trig ratio has O and A? Which trig ratio relates the opposite and the adjacent? It is a tangent function, right? So we're going to be using tan to solve the situation, okay? So we're going to have tan of the angle 29 equals opposite, which is x over adjacent. Remember, x is not the height of the tower. The height of the tower let me show it to you, is x plus 2. It's that x plus the height of the transit. Okay, so we have to be really careful about that. So the height of the tower is going to be x plus 2. All right, so let's go ahead and find out what x is, and then we'll add 2 to figure out the final answer. So to get x by itself, we multiply both sides by 85, and then we're going to plug that into our calculator. All right, so we're going to do 85 tan 32, tan 29. That will be the measure of x. So 85 tan 29. And then we get 47. It's basically 47 meters to the nearest integer. Okay? So let's go ahead and write that down. X is 47 meters. So is that a correct answer? Is the answer option D? Absolutely not. Remember, we need to add the height of the transit, okay, to x to get the height of the tower. Okay, so the height of the tower, is basically 47 plus the height of the transit, which is 2. So our final result will be 49. So the answer to this is option A. All right, so there you have it. All right, moving along to the next question, question 8. It says the picture frame below is a rectangle with dimensions 16 inches by 7 inches. What is the length of the diagonal of the picture frame? Okay, so let's see. If we draw a diagonal, what do we have? If we draw a diagonal for the rectangular picture frame in this orientation, you notice we have a right triangle. So we can basically use the Pythagorean theorem here because we're given two sides and we want to find the third side, okay? So what we're going to do, I'm going to extract this triangle, and then we're going to use Pythagorean theorem to figure out the side of the length of the diagonal, okay? That length right there is the diagonal. So let's go ahead and extract it out. So let's see. We have some measures that we know. The one on the bottom is 16, the horizontal length, and then the vertical length is 7 inches. And this is diagonal right here. Let's call it C. Okay? Why am I calling it C? Well, it happens to be the side that's opposite the hypotenuse. It doesn't matter what you call it though. So it's opposite the 90-degree angle. So this is the hypotenuse, and the hypotenuse using the naming system of the Pythagorean theorem is always C. Okay, so I'm going to call this A and B. Remember, the labeling of the legs are interchangeable. I can call this A and B and I'll still be correct, okay? So C is the diagonal. So we're going to use the Pythagorean theorem, C squared equals A squared plus B squared. And then we're going to have C squared equals 7 squared plus 16 squared. All right, let's plug that into our calculator and see what we get. Okay, so we have 7 squared plus 16 squared, which is 305. So C squared is 305. Let's write that down. C squared is 305. So C is going to be the square root of both sides. So let's root both sides. So C is root 305. Okay, so C equals root 305, and that's the length of the diagonal. And the answer is option C. All right, moving along to the next question. Question 9. It says triangle JKL is shown below. Which equation should be used to find the length of JK? Okay, so let's see. We're looking for the length of JK. So how about we call that X? This is the segment that we're looking for. All right, so now let's label. This is a right triangle. We'll have an angle, so we can use right triangle trig here. Sohcahtoa. Sohcahtoa. So let's see which one can we use. So let's see. We're going to label what we need and what we know, and then that should help us determine the right ratio to use, the right function to use. Since this is the angle under consideration, the side opposite that angle is going to be your opposite. Okay? And then this side right here is opposite the 90-degree angle. The longest side of the triangle is your hypotenuse. So which trig ratio relates O and H? It's sine, right? So we're going to go sine of the angle sine 33 equals opposite of a hypotenuse. All right? So to get x by itself, we'll multiply both sides by 34. 34, 34, and then we have x equals 34 sine 33. Let's plug that into our calculators. 34 sine 33. Final answer is, well, actually, we don't actually have to solve it. We're just supposed to just set it up, right? I'm doing x right here. So let's see, if we just want to focus on the setup, um, there goes the setup right there. Sine 33 equals x over 34. X is jk, right? So let's go ahead and make use of that. Erase the other stuff. They're not necessary. All right, so take that out, take that out. So we have, the answer is going to be sine 33 equals x is jk over 34. Okay? Sine 30 equals jk over 34. Final answer is option D. All right? Okay. Now the last question, question 10, it says, what is the approximate value of x in the triangle shown? So this is a right triangle trig problem again, because we have two sides and an angle. So let's see. This is the angle under consideration. So the question is, in Sohcahtoa, to find that angular measure, are we going to be using sine, cosine, or tangent? So this is the angle, so that means the side opposite the angle, that's going to be the opposite. And the other side we know is opposite the 90 degrees, which automatically makes it the hypotenuse. All right, so which trig ratio relates O and H? Opposite and hypotenuse. It's sine, right? So we have sine x equals the opposite, which is 13 over the hypotenuse, which is 15. To isolate x, we're going to take the inverse sine of both sides. So the inverse sine of sine x equals the inverse sine of 13 over 15. Okay? All right, so this cancels out. So we have x equals the inverse sine of 13 over 15. Let's plug that into a calculator and see what we get. Second function sine gives us the inverse sine of 13 divided by 15. Answer is 60.073 to the nearest decimal place. The 10th place is 60.1. Okay, so x is going to be 60.1 degrees. 60.1 degrees. And that is option D. All right, so that's that. So thanks so much for taking the time to watch this presentation, and please feel free to subscribe to my channel by clicking up here, and click like if you like this clip. And please, please, please post a comment to let me know what you think about this presentation. More clips coming from MapCoachShare.com. Thanks again, and have a wonderful day.